what you have to do is, well, you can't take the derivative right now and treat the top and bottom as if they're two separate questions. So what you do is this. Do some algebra, try to see if you can write it in a different form. In this case, I'm going to put x underneath each one, just using my algebra skills. Then simplify. Well, x squared over x, that's just x, minus. Now, square root of x, let me just write it in, that's really x to the 1/2, right? And then x is really x to the 1. So remember from algebra, when you're dividing two terms with the same base, you subtract the exponents, so it'd be 1/2 minus 1, which would be negative 1/2. So now, let's take the derivative. Derivative of x is 1. The derivative of the second term, negative 1/2 times negative 2, which will be positive 1, x to the subtract 1 from the exponent, negative 1/2 minus 1 is negative 3/2. And that would be the derivative. So, any questions? So if you have, let's say, y equals x to the 4th, or I should say f prime of x. So f of x equals x to the 4th. Just want to go over some notation here. So the derivative would be 4x cubed. If I want to ask you to take the derivative of the derivative, that would be called the second derivative. So that would be 3 times 4, which is 12x squared. Now, we could technically keep going. I could ask you what's the third derivative. So if you take the derivative again, that would be the third derivative. Now, once you get to the fourth derivative, we just put a little parentheses like that. In this case, it would be 24. And then the fifth derivative would be 0 and so on. Really just focus on first and second derivative right now, but I just wanted to show you the notation. Now, FYI, if you have the Leibniz notation that you're using, y equals x to the 4th, so the dy over dx would be the first derivative. The second derivative would be d squared y over dx squared, which would be 12x squared. And then third derivative, you just replace the 2's with a 3 and so forth. So I just want you to be familiar. So if you're reading a calculus book or another looking up something, and you see something like d squared y over dx squared, that means the second derivative. So it's just another way to write it.
Would you ever ask us to do it in that format, or do you care?
You will be so familiar with it, it will be just like reading English for you by the time you get done in this class.
Okay. So there wouldn't be like a problem saying write it in Leibniz.
I would say find the second derivative, d squared y over dx squared. So it would be written in both languages, English
I see.
and
Okay, makes sense.
You can always ask, hey, what does this mean? I'll say it's find the second derivative. It's not something I'm going to test you on. So if I say, hey, find that, and you can ask me, what is that? And I'll say that's the second derivative. If that's what you're worried about. So here's the question, find. So if I asked you this on a quiz, let's say, for example, find, you could tell that that's the second derivative, right? I'll say it like find f double prime of x, or find the second derivative if f of x equals square root of x plus x to the third. So you go ahead and try to do that. Now, before you can find the first derivative, you got to find the, I mean, before you can find the second derivative, you got to find the first derivative. Oh, Leah, do you remember if I did 3-1 and 3-2 on the same day last semester? I think she stepped away. All right, so let's go over this here. F of x equals, I'm going to rewrite it first, x to the 1/2 plus x cubed. The derivative will be 1/2 x to the negative 1/2 plus, what's the derivative of x cubed?
3x.
squared.
Yes. Now I'm not going to rewrite it because I'm going to take the derivative again so I can know what the second derivative is. So negative 1/2 times 1/2 is negative 1/4 times x to the, subtract 1 from the exponent, negative 1/2 minus 1 is negative 3/2. Plus, the derivative of 3x squared is 6x. All right. Now, let's talk about if you have S of t, that's the displacement function. So, or also called the position function. So if you have a particle or an object moving, we're talking about physics now, the position of the object is usually denoted by S as a function of time. V being velocity, that would be the derivative of the displacement function. So to get the velocity of the object, you take the derivative of S and you get the velocity. V is velocity. And if you take the derivative again, you'll get the acceleration. So the second derivative of S would be the acceleration. Or basically, if you take the derivative of velocity, you get acceleration.
So when they're asking for acceleration, they're actually asking for the derivative twice, right? Of your
Yeah.
displacement function.
So when you take physics, like the calculus-based physics, I don't know what it's called at Fluid in college with the number, but the one where calculus 1 is the prereq, and you could actually, you'll see that when you take the derivative of the displacement function, it's velocity. And then when you take the derivative of velocity, because remember, derivative is the rate of change. So the rate of change of your position is your velocity. And how fast your velocity changes is acceleration. So I wanted to do a problem here in the book. Let's do question number 50 from the book on section 3.1. S equals t to the fourth minus 2t to the third plus t squared minus t. So here's the question. The equation of motion of a particle is S equals that, where S is in meters and t is in seconds. And then they ask you a series of questions. Part A, find the velocity and acceleration of the functions as functions of t. So velocity, v of t, or just v, is a derivative. So it would be 4t to the third minus 6t squared plus 2t. What's the derivative of minus t? Anyone know?
-1.
Yes, very nice. And then to get the acceleration, is going to be the derivative of velocity, which would be 12t squared minus 12t plus 2. So that's the answer for A. They wanted the velocity and acceleration. Now in part B, they asked, find the acceleration after 1 second. So basically they're asking you plug in 1 into the acceleration function. So we got 12 minus 12, which is 0 plus 2 is 2, and it's meters per second squared. Your physics professor will explain to you units, but if velocity is meters per second, acceleration would be meters per second. So it's meters per second squared. This is what you would write it as. All right, and then C, they said graph it on a graphing calculator. We're not going to do that. All right, so now you know how to, one of the things derivatives is used for is besides the slope of the tangent line, is velocity and acceleration. Now, let's go back and talk about finding the equation of a tangent line. Now, if I were to ask you to find the equation of a tangent line, you would just do it very quickly. You will only use the limit definition of derivative if I say flat out, use the limit definition of derivative. Now, having said that, can I scroll? You guys wrote all this down? All right, here we go. This is just a general graph that I'm going to draw here. So if I wanted to know, so let's say the slope of the tangent line at a particular point. So that would be the tangent line. Let me see if I can pick this up. Okay, never mind. So this right here is the tangent line. Now, where it just touches it at that point. Now I'm going to show you another line. And this line right here, blue line, where it crosses the tangent line at a 90-degree angle, that's called the normal line. And for short, sometimes we call it the norm. So it's basically, so imagine you got a curve here. The tangent line is the one that just touches it at that point, and that's the only, it just kisses it at that point, and that's it goes away. The normal line, it's like hits it at a 90-degree angle. So it's like the perfect angle to, let's say, stab that balloon, so to speak, if that makes sense. So you got to be able to get the equation of both. So we're going to do both now. So here's the first question. Find the equation of the line tangent to f of x equals x squared minus 6x at the point 2, -8. Now, that graph that I drew up there is not the graph for this problem. That's just the general graph, just trying to show you what a tangent line and the normal line is. So you've done the equation of a tangent line last time. So first, you got to take the derivative. And just take the derivative quickly, 2x minus 6, boom. I never said use the limit definition derivative, so you don't need to do it. You just take the derivative, boom. What's the next step?
I think we plug in 2 into the x.
Yes. Four minus 6, which is -2. So that's the slope of the tangent line. Now we need to get the whole equation. So we got y equals -2x plus b. Oh, we got 35. We have one more than I accounted for. There's someone on here with 2 devices? Daniel, is that you?
That was me.
Oh, Darian.
Sir.
That's you. Oh, Daniel is just one device, right?
Just one.
So now we got to figure out b. Well, you know it goes through 2, -8. Add 4 to both sides. Daniel, were you here this whole time? I haven't heard from you.
Yeah, I've been here the whole time.
So once you get b equals -4, y equals -2x minus 4. All right. So now we'll do finding the equation of a normal line example. So same function, f of x equals x squared minus 6x. This time find the equation of the normal line. We're not going to get too much of 3.2 today. Sorry, you guys. I know you're a little disappointed, especially Madison.
I'm very
She
hurt.
wanted 3 sections, but I had to tell her before class, no, no more than 2.
It's too much betrayal. Sorry.
Yes, how dare you, Professor? I wanted to do a ton more math today.
Quit trying to
Hey.
kill us.
All right, so I'm gonna get moving on this here. So the derivative would be the same, 2x minus 6. You plug in x equals 2, just like before, into the derivative to get the slope of the tangent line, which is -2. So that's the slope of the tangent line. The slope of the norm would be the negative reciprocal, right? Remember from algebra, if two lines are perpendicular, then the slope of the one line is the negative reciprocal of the other. So m is going to be positive 1/2. That's the slope of the norm. So you go y equals 1/2 x plus b. So in this case, you plug in 2 for x, -8 for y. Solve for b. B equals -9. So the final answer will be y equals 1/2 x minus 9, and that's how you get the equation of the norm. So we gotta somehow get through 3-2, 3-3, and 3-4 this week. But their 3-2 and 3-3 are pretty quick. And I can pretty much do the highlights of 3-3 right now. Then I'll talk about the details of it after I talk about 3-2. But this is information you don't need to know for the quiz this Thursday. I just want to talk about a few things. So they're coming up. So let's just go over some derivatives here. And again, you don't need to know this for this Thursday's quiz, but I just want to get started on a few things. So when I run through 3 sections, it's not going to, 2 of them are going to be quick. We will have time on Thursday. So this is a 3.3 preview.
Professor, I'm so sorry, quick question. How do we get 1/2 on the top up there on the slope of the norm?
Yeah, so the derivative, so we got, this is -2, right?
Yes.
You see the -2 here?
Yes.
So since the norm is the perpendicular to it, so this is a general graph. See this blue line, how it's perpendicular to the red line? 2 lines that are perpendicular have the negative reciprocals of each other.
Oh, okay. Okay, thank you.
So -2/1, you flip it over and change the sign, it's positive 1/2.
Okay, thank you.
Trig functions, all right. So you know your 6 trig functions, right? You've heard of sine, cosine, tangent, cosecant, secant, cotangent. Okay, now, if you have y equals sine of x, the derivative of sine of x is cosine of x. If you look through the book, somewhere in the book, they'll prove it to you. They'll say limit as h goes to 0 of sine of x plus h minus sine of x all raised. They'll use some trig identities. 10 minutes later, you'll get cosine of x. But for now, you're going to have to take my word for it. You trig. Thank you, Daniel, for your opinion. All right. Now, you will never guess what the derivative of cosine of x is.
Sine x.
That's a very good guess, but it's negative sine of x. See, if you said negative sine of x, I would say you're repeating this class. So sine of x is probably as good of a guess as you could have gave me. So the answer is negative sine of x. But you only know that if you've seen it before. Now, y equals tangent of x. What's the derivative of that? Now, on Thursday, I'll prove to you how you can get tangent of x if you forgot it. But the answer is going to be, the derivative of tangent is going to be secant squared x. And then what you got, let's say we got y equals secant x. What's the derivative of secant? It will be secant x times tangent x. Now, by exam time, I would make you memorize these four. But again, you're on your own. You got to be self-disciplined. It's really hard for me to see how much you memorize on an online test. You just you're going to be on your own next semester. I don't know what's going to be next semester. Probably be online again. From
Professor,
Yeah.
are things that we have to prove, or you just want us to memorize them? Like, I'm not going to have to prove why.
No, you won't have to prove it. You just gotta.
Okay.
I can't make you memorize it, but I would say yes. If we were taking a test in class, you would have to memorize it. Yeah.
Okay, thank you.
Now the next two, I'll show you a trick on how to remember it. I'll write it in blue or red actually. Y equals cosec x. It's cosecant. The derivative is negative cosecant x times cotangent x. And then last one, y equals cotangent x. Y prime is equal to negative cosecant squared x. You know what? Let me rewrite the cosine here as well. All right, so let's talk about this here. And we're going to talk, you do not need to know this for this Thursday's quiz, so don't stress about it. You will need to know it for next week's exam though. So the derivative of sine is cosine. When you do the homework for 3.3 lessons, derivative of cosine is negative sine. Derivative of tangent is secant squared. And secant is secant tangent. So the average student will know these four by the time they do the homework and they get introduced to this for a few weeks. They'll know these four. I want to show you a little pattern though. The co-functions, cosine, cosecant, and cotangent, see the ones that I put in red? Those are the co-functions. Cosine, cosecant, cotangent. They're the ones that have a negative answer in their answer. That's the easy way to remember it. The co-functions, their derivative will have a negative sign. Cosine is negative sign. You'll have that memorized, no problem. Now, the two on the bottom that are red, those are the hardest to remember. So the way I remember it is, if secant is secant tangent, cosecant is going to be cosecant cotangent, well, with a negative sign. And if tangent is secant squared, well, cotangent is going to be cosecant squared with a negative sign. Now, just do me a favor. Have this on a sheet of paper on the side, not in your notebook, but on a separate sheet of paper where it's on the side. So when I lecture to you on Thursday, you can keep referring to it really fast. I'm not expecting you to have it memorized on Thursday, but you have it on a sheet of paper like I have right now, off to the side of your desk. So you can quickly refer to it as we do problems, okay? And then of course, the other thing that we got in, you got y equals e to the x. We went over that. The derivative of is e to the x, but that won't be on the test because we're going to do other exponentials. So you got a lot between now and they ain't that bad yet. So yeah, exactly, Omar. So what we want to do here is I want to get you. So let me tell you our schedule. The quiz this Thursday is going to cover these sections. The 2.7/2.8 section, which is basically, I'll tell you what the question is going to be. Question number 1. Find f prime of x using the limit definition of the derivative. So that's that limit as h goes to 0 of f of x plus h. That's going to be the first question. Question number 2 is going to be section 3.1, maybe a part A and B. Just take the derivative quickly. Just, pretty quick forward, and that's it. Those will be your questions. Maybe 2 of them for number 2. So look at part A and a B, since it's quickly. Now, the trig, we're going to continue on with that. And then, of course, we're going to do 3.2 first. So on Thursday, we're going to do 3.2, which is, well, what happens when it's a multiplication or division? How do you do that? Because I showed you when it's addition or subtraction, you just treat them like separate questions. Well, what if it's a product or a quotient? We'll talk about that. And then 3.3, we'll spend some more time on the trig. Those 2 combined should be like one section. Then we'll do 3.5. So that's nice. Then we'll do 3.4, which is the chain rule, which is the main section that we're going to be doing right after I get through those on Thursday. Now, I'm pushing a lot, but then I'll eliminate a couple things like exponential and something else you're going to run into in 3.4. Friday, I'm going to post on Canvas a review sheet for you. So the good news is Tuesday next week, I won't cover anything new. I'm just going to go over the review sheet. So you try to do as many of them as you can over the weekend. And then we'll go over the review sheet, every single problem, along with any other questions you have from 3.1, 3.2, 3.3, 3.4. I'll just answer all your questions on all those. And then Thursday next week is your exam number 1, which would be, you make the exam about like an hour and 15-minute length. And that's all we'll do that day. So then you just leave. Any questions regarding our schedule and material for this week and next week? How many questions on the next week's exam? I don't know. Will the test have questions like you do in class or like the hard problems in the homework? Somewhere in between. It'll be a little bit of everything. It'll be easy questions, tougher questions. A couple of the questions in the homework, some of the questions in the homework are pretty ridiculous. Like I was doing a limit problem in my morning class. I'm like, how do they know to factor out the square root of x where the answer ends up going to infinity? I think my exams are pretty fair.
You get a page front and back?
Yeah.
Okay.
Let's see, anything else?
Do you provide a study guide for each exam or no?
Yeah, I'm going to post a review sheet on Friday, around Friday, hopefully. So you do it over the weekend, as much of it as you can, and then we'll go over it on Tuesday.
Okay, thank you.
And then now again, this when I post it, that's not the only thing you should study. Anything that I assign for homework, be able to do the easy and medium difficulty problems. I'm not going to ask necessarily. I mean, anything that I put assigned for homework that you're responsible to know how to do. I don't want you to just study like the 10 or 15 questions that I put on the review sheet and say, oh, the exam will look just like this. I'm not going to do that. Having said that, trust me, my exams are pretty fair. You're better off taking my exam than Professor XYZ. Let's just leave it at that.
How is the test going to work? Like for our quizzes, it's only a few questions, but how are we going to?
Oh, yeah. So it's very similar. The only difference is I put the PDF file, attach it to the assignment. So you would click on it and you would download it and print it. If you don't have a printer, you just look at it on your monitor. And you would use, if you have a printer, it's perfect. You just write on the test. If you don't have a printer, you use your own sheets of paper, but you're going to keep the same format as the exam. So Rachel, do you have a printer?
Yeah.
Okay, so you print it and you'll do exactly what it says on the paper. You have no problem.
Okay.
Then
Thank
it'll
you.
be, let's say it's 4 pages or whatever. Then you just scan the 4 pages into one PDF file. That's why I made you do that on the student information sheet, so you know how to make it one file. And that's it, yeah.
Okay, thank you.
Any other questions? But right now, let's worry about the quiz. This Thursday, quiz number 3. I told you the 2 questions right here. And let's see here. Maybe anything else I want to talk about before I use up the... So I don't run out of time here. So what happens here is, we'll talk more about this in on Thursday. But so far, when I say take the derivative, so if you have y equals, let's say, x to the 5th plus e to the x, the derivative is 5x to the 4th plus e to the x. The e to the x is easy. I keep saying it's not, don't worry about it, because it'll get more involved when I throw other things into it. Now, the problem is if it was multiplication, like y equals x to the 5th times e to the x, you can't just take the derivative of each one individually. You have to do what's called the product rule. So, and then the product rule will be, which is what we're going to talk about next class meeting, is if you have y equals f times g, the derivative is not just the derivative of each one individually. You're going to take the derivative. Here's the rule for it. Let me just write it. So let's say f is the first part, g is the second part. So f is the first part, g is the second part. So the derivative would be f, which is the first part, times the derivative of the second, plus the second times the derivative of the first. And then from there, we'll go from there. But anyway, we'll talk about that more later on Thursday. So right now, just focusing on doing the 3.1 homework, understand it really well, and study the limit definition of derivative from 2728. And then we'll stick around if you have any questions. We've got like 15 minutes left. Otherwise, you can take off.